Hey class, it's Mr. M here to finish discussing something that we kind of rushed at the very end of class, and that's using trig ratios in reverse to find angle measures. So if you recall in class we talked about how you can take a table of values of data and go in two directions. For example, the example we looked at is you can figure out the price of an item on a menu, and if you know the price you can also figure out what the item was before someone bought it, right? You can go in two directions. And this concept can also work in trigonometry, since a trig ratio is a fixed value relative to an angle, right? So typically what you do in a lot of problems that we've done so far is this first part. You find the trig ratio, either sine, cosine, or tangent, of some angle measure, like 30 degrees, or 45 degrees, or 28 degrees, whatever it is. Trig ratio, sine, cosine, or tangent of an angle, punch in the calculator, and it equals, right? It equals some ratio, right? Well, you can also go in reverse. You can also flip-flop these around and say, okay, I don't know what the angle is. I want to get the angle, but all I have is a ratio. Well, you're not going to use trig for that. You're going to use what's called an inverse trig ratio. And these are these three: inverse sine, inverse cosine, and inverse tangent. These are also known as arc sine, arc cosine, and arc tangent. You're going to use the inverse ratio to produce the angle, right? They're going in opposite directions, as this thing here kind of shows. Okay? So let's see that in practice. Here you have this problem. Find angle I and angle J. And we're given those two sides, 12.4 and 19.5. I'm going to start with angle I first, just because it's first in the question. Doesn't matter where you start. Angle I. Well, I don't know what it is, obviously, duh. But we do know that we have these two sides, 19.5 and 12.4. And relative to angle I, right, compared to angle I, 19.5 is the opposite, and 12.4 is the adjacent. It's right across from, and it's right next to, respectively. So opposite and adjacent. Well, I'm going to refer back to our old friend SOHCAHTOA. Sine. Do we have opposite or adjacent? Just opposite. That's not going to work. Cosine. Adjacent, but no opposite. Adjacent hypotenuse. Aha! Tangent. Tangent of an angle is equal to the ratio of opposite to adjacent. So that means the tangent, so this is the one we're using, the tangent of angle I, which we don't know what it is equal to the opposite over the adjacent. Tangent of angle I is equal to opposite, 19.5, over adjacent, 12.4. Well, 19.5 over 12.4 is just a ratio. It's a proportion, right? 19.5 parts compared to 12.4 parts. So I'm going to go ahead and divide those in the calculator, and it's going to give me 1.573, just to be precise. 1.573, that's tangent of angle I. Well, remember, this is an angle. We don't know it, but we have the ratio. So here's where the flip-flop comes in. This is just a way I like to look at it. I want to invert these, literally flip them. So no longer is it tan of I, but rather trig of this ratio, and that's going to give angle I all by itself. But since I flip-flop these are no longer going to be tangent ratios. These are going to be what are called inverse tangent ratios. The inverse tangent of this ratio will give me the measure of angle I. So making sure my calculator is in degree mode, and it is, I'm going to press second tan, or inverse tan. Second tan, 1.573. And looking up in the table, the calculator finds the inverse tangent is 57.55 degrees. 57 point, let's call it 6 degrees. So this angle here is 57.6 degrees. Now you can do the same process again to find angle J, but, you know, life is short. We're always trying to find good ways to speed things along. Angle J, well, come on, all triangles make 180, right? And in fact, 90 of those angles are already at angle K, so you already only have 90 degrees left over, which suggests that I and J are complementary angles, right? Complementary angles, which means 90 minus 57.6 will give you the complement of that angle. And 90 minus 57.6 is 32.4 degrees. So there's angle J, 32.4 degrees. And there you have it, angle I and angle J.